Hey guys, today we're going to go over a really simple way to prove a surprisingly large number of statements in math, and it's called proof by contradiction. Now the whole idea of this method of proving things is that if something is not wrong, then it must be right. Now, okay, that sounds easy, but let's take an example. Okay, so the example I've chosen is prove by contradiction that there are infinitely many integers out there. Well, remember what I said about the whole idea of something being not wrong, being right? Well, the first step of any proof by contradiction is that assume the statement is wrong. So assumption, there is a finite number of integers. Now, what are the implications of our assumption? Well, if there's a finite number of integers, then there must be a largest integer, right? Because its number of integers out there is finite. So let n largest be this largest integer. But the problem is, n largest plus 1 is larger than n largest. So this is clearly a contradiction. So therefore, we were wrong in assuming the statement was wrong, so the statement must be correct. Oh my god, I can't type! Okay, let's jump that up a notch. So let's prove by contradiction that there are infinitely many primes. So again, we begin by assuming the opposite. So our assumption is that there's a finite number of primes. We assume that this statement is not true. Well, the way we tackle this proof is a bit different from how we tackled the last proof. Well, basically, if there's a finite number of primes, then there has to be a smallest prime and there has to be a largest prime. So let's call the smallest prime n1, where this is the smallest prime. And let's call the largest prime nn, when nn is the largest prime. Well, all the primes that exist in our assumed universe can be expressed by P, where P is this set. So n1, n2, n3, n4, all the way to nn. So what this means is nn is the smallest prime, and it's also the first prime. n2 is the second prime, n3 is the third prime, n5 is the fifth prime, and nn is the nth prime, also the largest prime in our universe where there's a finite number of primes. Okay, now let's create a new number. This new number is called y. And what y is y is n1 times n2 times n3 times n4 times n5 times n6 times n7 times n8 times all the way to nn. Well, if we bracket this shit and we add 1, we have a new prime. And I'll explain this in a second. But basically, if y is a new prime, y is larger than nn, but nn is the biggest prime, and y is a prime that's bigger than the biggest prime, this is clearly a contradiction. The conclusion: we were wrong to assume that the statement was wrong. There's an infinite number of primes out there. Now, if you're a bit confused as to why y is a new prime, well, consider this. Any number that's not a prime can be expressed as a product of prime factors. Well, let's just illustrate what that means. So if I have a number, let's just say 56. 56 is not a prime, because 56 divided by 2 is 28. 28 divided by 2 is 14. 14 divided by 2 is 7. So 56 is 2 times 2 times 2 times 7. So 56 is 2 to the power of 3 times 7. So any number that's not a prime can be expressed as a product of prime factors. As you can see, 2 is a prime and 7 is a prime. Well, what happens if we try to divide y by a prime? Well, y divided by this, let's just say n1, is going to yield a remainder of 1. Y divided by anything, nn, is going to yield a remainder of 1. Y divided by n2 is going to yield a remainder of 1. Because if you imagine this happening, you'll just get, so let's just say y, so what's y divided by n2? Well, that's just going to yield you n1 times n3, missing the n2, times n4, all the way to nn, plus 1 over n2. So that's why y is a prime, because n1 times n3, missing the n2, times n4 times n5 times n6 times all the way to nn will be an integer, and 1 over n2 will be a fraction. Therefore, y can't be divided by any prime number within our subset P. Therefore, y can only be divided by 1 and itself. Therefore, y is a new prime that's bigger than all the previously thought primes to exist. Therefore, that's a contradiction, and therefore there are infinitely many primes. And yeah, that's why there's infinitely many primes out there. Because if you have the smallest prime and the largest prime, and every prime in between, you can use them to create a new prime. So there's infinitely many primes out there. This is actually a proof by Euclid, and it's a really famous proof because it's so simple. You can try it yourself, see if you can make any new primes. I guarantee you that you can. But yeah, that was the video. I hope you enjoyed. I hope you learned something new. And I'll see you guys again next time.